Welcome to Ask and Learn.
So we want to graph the function f of x is equal to x squared times the natural log of x. We want to use L'Hopital's rule to explain the behavior as x approaches 0, and we want to estimate the minimum value and intervals of concavity using the graph, and then use calculus to find the exact values. So I went ahead and plotted a graph of f of x here. So the first thing they told us to do was to graph it, which we already did. Now let's go ahead and use L'Hopital's rule to explain the behavior as x approaches 0. Right. So since this function is undefined on the left, we're going to need to look at the end behavior to the right. So we want to look at the limit as x approaches 0 from the right of x squared natural log of x. And now if we were to just go ahead and plug in 0 from the right, x squared goes to 0, and natural log of x goes to negative infinity. So if we want to use L'Hopital's rule, we're going to need to rewrite this so it's 0 over 0 or infinity over infinity. So to do that, we can go ahead and write it as natural log of x over 1 over x squared. And now, if we were to go ahead and evaluate this, it would be negative infinity over infinity, which tells us we can apply L'Hopital's. All right, so let's go ahead and apply L'Hopital's rule. So now this will be equal by L'Hopital's rule to the limit as x approaches 0 from the right of, so the derivative of our numerator, which is going to be 1 over x, over the derivative of our denominator, which is going to be negative 2x cubed. Now we can use a little bit of algebra to rewrite this as the limit as x approaches 0 from the right of negative 2x squared, and we know that this here will approach 0. And if we look at the graph, that does explain the behavior of this, because it does look like it's getting closer and closer to 0 for this point. Now, for part C, we wanted to find our minimum value, and so just kind of going through the graph here, that point I have on the graph looks like about what our minimum should be. And then we also want to check for change in concavity, and it looks like around 0.2 we have a change in concavity. So this would be 0 to about 0.2. It looks like the function is concave down. And then from 0.2 to infinity, it's concave up. All right, now let's go ahead and use a little bit of calculus to actually find what our minimum and the concavity interval should be. So let's just write it down again. So f of x is equal to x squared times the natural log of x. So first derivative will be, so f prime of x. Well, to take the derivative here, we're going to have to use product rule. So it's the first function times the derivative of the second, so d by dx of natural log of x. And then plus, then in the opposite order, so natural log of x times the derivative with respect to x of x squared. So the derivative of natural log of x is 1 over x. The derivative of x squared is 2x. And now we can go ahead and simplify this to x plus 2x natural log of x. All right, now to find our critical values, we want to set this equal to 0. And actually, before we do that, let's go ahead and factor this. So I'm going to pull out an x. So x times 1 plus 2 natural log of x. All right, now let's go ahead and set this equal to 0. So this tells us either x is equal to 0 or 1 plus 2 natural log of x is equal to 0. So we can subtract 1, divide by 2, and that would give us natural log of x is equal to negative 1/2. Exponentiate each side. So we get x is equal to e to the negative 1/2. So it didn't look like our minimum value was here at x is equal to 0, so we could just go ahead and ignore that one. And since that's also on the edge of our domain, we would know that that value there shouldn't be included anyways. So our minimum occurs at e to the negative 1/2. And let's just go ahead and plug that in to see what we get. So f of e to the negative 1/2 is going to equal to e to the negative 1/2 squared times natural log of e to the negative 1/2. So e to the negative 1/2 squared is just going to become e to the negative first power, and then the natural log of e here cancel out, and we're left with negative 1/2. So we get negative 1 over 2e. So this here would be our minimum value at x is equal to e to the negative 1/2. Next, let's go ahead and find our concavity interval. So f double prime, so f prime, let's go ahead and write that first again. So f prime of x was equal to x times 2 natural log of x plus 1. All right, so now to find f double prime, we'll go ahead and use product rule again. So we write the second one, take the derivative of the first, and then add them in the opposite order. So x d by dx of 2 natural log of x plus 1. So the derivative of x is going to be 1, and the derivative of 2 natural log x is going to be 2 over x, and the derivative of 1 is just going to be 1. So we can go ahead and rewrite this as 2 natural log of x plus 1, and then the x's over there cancel out, so we're just left with plus 2. So this is going to be 2 natural log of x plus 3. Now let's go ahead and set this equal to 0. And that's going to tell us that we will get, so subtract the 3, divide by 2, we get natural log of x is equal to negative 3/2. And exponentiating each side, we get x is equal to e to the negative 3/2. So now we would just go ahead and use this for our interval. So we knew it looked like, so if we come look over here again, it looked like it was concave down to start. So from 0 to e to the negative 3/2, we will say this is going to be concave down. And then from e to the negative 3/2 to infinity is going to be concave up, it looks like. So we ended up getting our exact interval for concave up and concave down, as well as our exact minimum.